Hello, everyone. My name is Mauricio Velasco, and I'm part of Splunk's threat research team. In this short video, I'm going to be talking about the content and or the detections that we worked on as part of our November release, specifically the Active Directory lateral movement analytic story. In this session, we're also going to be going over a demo where I'm going to simulate some of these lateral movement techniques and show how we can detect them with the content that we are releasing. Okay, let's go ahead and start. Um, First, let's talk about lateral movement. What is it? Well, lateral movement are the techniques that adversaries use to control remote systems on a network. Let's think about how breaches happen. When a breach happens, attackers usually obtain an initial foothold through maybe a misconfigured server, a vulnerable service, a weak password, a phishing attack, right? And once they obtain that initial foothold, once they're controlling that first endpoint, it's really unlikely that they're going to be able to find their objectives in that first host, right? So they're going to need to expand their access and explore the network by moving laterally until they find what they're looking for, which could be a database server, an email server, a file server, etc., right? So since lateral movement is often a necessary step in a breach, we think it's really important for cyber defenders to deploy detection coverage for it. There's many ways of moving laterally in an Active Directory network, but the content that we wrote focuses on abusing native administrator Windows services. This is a common way attackers use to move laterally once they have obtained administrative credentials. So services or features like the Service Control Manager, the Task Scheduler, WMI, WinRM, etc. They're all legitimate features that attackers can interact with through the network to achieve code execution on remote endpoints. So that's going to be the focus of our detections. Now, if we analyze some of the open source threat intelligence that we have available, we can learn how attackers are moving laterally in the wild, right? For example, Nobilium, the actor who carried out what has been named the most sophisticated nation state cyber attack, they abuse the task scheduler using SCH tasks. They also abuse WMI using PowerShell to execute or try to execute code remotely, as we can see on these reports. The Ryuk ransomware, they've known to leverage WMIC to, again, leverage WMI to execute code remotely. Conti ransomware group, they use PSXSec to move laterally, a legitimate administrative tool, right? So let's start. Well, first, that's why, knowing that actors are leveraging these techniques, we wrote the Active Directory lateral movement analytics story. This current update introduced 25 new detections and 5 modified detections. And we focused on these data sources, process and command line logging, PowerShell script logging, as well as the Windows security event log. Okay. All right. So let's start with the demo. So in this demo, we're going to use attacker tools or simulation tools like InPacket, Metasploit, PurpleSharp, and we're going to simulate these techniques in a lab environment will be built with the attack range, and we're going to be detecting these lateral movements attacks using Splunk. All right, so let's move into our demo. So we have an attack range where we're gonna infect one server or Windows server, and then we're gonna move laterally to the domain controller from this server, okay? For this, we're gonna be using Metasploit, and we already have Metasploit listener listening here. There's no active sessions. And then we're just going to infect this computer, assuming compromise. We don't know how this attacker got in, but they got in and they have access. So now with this endpoint, we're going to move laterally from here to the domain controller, again, assuming that the attacker has already obtained credentials. So the first way that we're going to move laterally is by using Metasploit's implementation of psexec, which is pretty similar to the psexec binary from sysinternal. So we're going to configure this. I'm not going to go over the details what we're configuring here, but we're going to use psexec against the domain controller, which is IP14. Okay. All right. So we're going to, one important thing is Metasploit has different ways of executing psexec. In this case, we're going to run the most common way, which involves uploading a service binary. So we're going to run this. And Metasploit, got us, this worked, and now we are running code in the domain controller. So we've moved laterally, right? Using Metasploit's psexec. So if we look at the logs and try to see what happened here, I have a dashboard already created. We can see something interesting. The way psexec works is they write a binary, a service binary in an administrative share, and Metasploit's implementation does that similar. So we can detect binaries being written using this detection, and we can actually see where it came from and the user that it was used to create this service binary, right? So that's one way of detecting it. Another way is, of course, using psexec and similar tools will create a Windows service. In this case, we see that this service was created, the service name, and also it has a high entropy because, as you can see, Metasploit creates a random service. Now let's do something slightly different now. So we're going to use a different way of this technique. In this, we're going to avoid dropping a binary to disk. So we're going to try to bypass that detection that I just showed you. In this case, we're just going to execute a PowerShell one-liner to get our remote shell. So we run this, and this works. Now we have another session. And now we see, remember this detection that didn't trigger? Now we refresh, it should trigger. And we will see here that services.exe spawned cmd.exe, which spawned PowerShell. And this is a PowerShell one-liner that injects the Metasploit shellcode into memory, which is how I got that extra shell. So that's the first demo, and we're able to detect both ways. So let's move on. And in this demo, we're going to leverage this endpoint and set up a SOX proxy so we can run a tool from our command and control server through the SOX proxy into the target network. So I'm just going to set up a SOX proxy here using Metasploit, and now we're going to back up to our Kali Linux, and then we're going to execute this. So we're going to use the in-packet library, specifically the atexec.py, which abuses the task scheduler through proxy chains. So we're going to do that, execute, and we're going to execute the ipconfig command. So as you can see, this worked. And if we go back to our second dashboard, we see this. So we see that we are able to detect the in-packet command line parameters running ipconfig. And we also see that a new schedule task was created with a random name. In this case, this is the entropy, the Shannon entropy for this task name. Okay, so another way of detecting it. So finally, we're going to run a few more techniques, but in this case, we're not going to use Metasploit anymore. We're going to use Purple Shark, which is an simulation and emulation automation tool. So we're going to use, we're going to simulate 5 or 6 techniques in an automated way. Things like SEH tasks, SC, PowerShell and WMI, PowerShell and WMIG, WinRM, etc. So just in an automated way to make things faster. So we're going to confirm if Purple Shark is here, and then just going to run those 5 or 6 techniques. So I'm going to put this video on hold so we don't have to wait for this to finish. Okay, so now we know that Purple Shark has finished. And as we can see, it executed a bunch of techniques using the command line like SEH task to create a scheduled task, SC, WMIC, etc., PowerShell. Let's look at those, the detections that were triggered by running this. And this should start populating with all the hits that we're gonna get on these detections. Let's see, yep. So for example, SC was used to create a service, SC was used to start a service, SEH task to create a scheduled task. Yeah, we run the scheduled tasks. In this case, we're using WMake that reorg malware does. Now we're using PowerShell like Nobelium did, and we're using invoke command to abuse WinRM, right? So all of them caught by our detections. So that was it for this short video. Appreciate the audience. And yeah, that's my name, and reach out if you have any questions. So yeah, you guys have great end of the year. Have a good one. Bye.